Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at logarithmic modelling. Logs are used widely in other subjects, for example, calculating the pH of an acid in chemistry or in music. We're going to look at an example in physics where we're using decibels to measure the loudness or intensity of a sound. So I've given a scale here with a decibel measurement on the left and a corresponding sound on the right to give you an idea of what we're talking about. But everything on this scale is in comparison to 0 decibels. A sound at 0 decibels is basically the softest sound that the average human can hear. At 0 decibels, the energy of that sound wave is about 10 to the minus 12 watts per meter squared. So everything here is in comparison to that. Each time you go up by 10 decibels, you're multiplying the intensity of the sound by 10. So 10 decibels is 10 times more intense than at 0 decibels. 20, this is 100 times the intensity at 0 decibels. 30 is 1,000 times, 40 is 10,000 times the sound at 0 decibels, and so on. All of these are in comparison to this here. This is a logarithmic scale. It's not linear. So we're not going up by the same amount of intensity each time. As I said, each time we go up by 10 decibels, we're multiplying the intensity tenfold. So this is the formula for calculating the number of decibels. Again, we have here a ratio. Everything is in comparison to the limit of human hearing, to the softest sound a human can hear. So it's the ratio of the intensity of a given sound to that limit of human hearing. You take the log base 10 of that, and then you multiply by 10. We multiply by 10 because there are 10 decibels in 1 bell, which is like the unit of sound. All right, let's use this formula to answer a few questions here. So a sound is 320 times more intense than at I0 than here at 0 decibels. So how many decibels would this sound be that's 320 times more intense? So the number of decibels, which is Y, is simply 10 log base 10 now. If the sound is 320 times more intense, this ratio is equal to 320. This divided by I0 is 320. So you can put that straight in your calculator, and we get about 25 decibels. So a sound at 25 decibels, which is just more than rustling leaves, is about 320 times more intense than the softest sound a human can hear. So let's say now, this time we know the number of decibels. This time it's 32. How many times more intense is this than the sound at I0? So this time we have Y equals 32. And what we want to know is the ratio X over I0. So the next step is to divide each side by 10. And now if we want to get rid of the log base 10, we raise 10 to the power of each side. So 10 to the power of 3.2 would give us the ratio X over I0. And 10 to the power of 3.2 is around 1585. So that means that at 32 decibels, the sound is about 1585 times more intense than at 0 decibels. Because here we're just interested in the ratio. We're not actually interested in the intensity of the sound. We're interested in how many times more intense it is than the sound at I0. And that's actually how you use this scale here. If you want to find how many times more intense a sound is than at I0, you simply divide by 10 and raise 10 to that power. So for a loud truck, 80 divided 10 is 8. So this is 10 to the power of 8, or 100 million times more intense than the sound at 0 decibels. So remember, each time we go up by 10 decibels, we're multiplying the intensity by 10. So like a helicopter would be 100 times more intense than the sound of a loud truck. All right, let's do this question here. What happens to the intensity if we increase the sound by 1 decibel? So let's calculate the intensity at 1 decibel. So if we have 1 equals 10 log of the intensity over I0, we're going to do the same as what we did in the last question. So what we're going to do is we're going to divide by 10 and then raise 10 to that power. So 1 divided 10 is 0.1, and raising 10 to that power, we get x over I0 equals 10 to the power of 0.1. And that gives us 1.26. What that means is each time you increase the sound by 1 decibel, the intensity is multiplied by 1.26. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.